For example 1, find the derivative of y squared is equal to x by first solving for y. So we have ourselves an implicit equation. Y is not a function of x, it is two functions of x, as we saw from a previous exercise. And one of the ways to take the derivative, of course, is to solve for y, get the explicit equations for y, and then take the derivative normally, like this. So we already know that y is equal to plus or minus the square root of x when we take the square root of both sides. But it might be handy to actually rewrite that as plus or minus x to the 1/2 power so that we can use the power rule on it. Now, I could separate these two things, this positive square root of x and the negative square root of x, and then take the derivative separately, but I could just as easily do them together because all we have out front here is just a positive and negative constant. Okay, so watch. I'm going to write dy dx, or y prime if you prefer, is equal to, let's leapfrog that power down, plus or minus 1/2 x to the, subtract 1 from that, negative 1/2. All right, and then rewrite stuff with positive exponents. That will be plus or minus 1 over 2 square root of x. So once again, we do actually have two derivatives. We've got y prime is equal to positive 1 over 2 square root of x. And then we also have y is equal to 1 over, negative, how about that? 2 over the square root of x. Why is that? Why is that? Here, let's come back to these pictures here, because we've got basically a derivative for the top, and we have one separately from the bottom. But you know what? Like, if that's what we had to do in order to take the derivative of an implicit equation, sometimes it would be absolutely impossible, because sometimes you can't get an explicit expression for y for each of the individual functions. So, we have this other kind of method. It's called implicit differentiation, which, is what the lesson's all about. Yeah, so let's see how we're going to do that implicitly. So, before we start, let me just kind of help you conceptualize what's going to go on here with the y's. So we want to kind of think of y with some functions of x embedded in it. And we know that if we're going to take the derivative with respect to this guy, that we'd have to use the chain rule. It'd be the derivative of the exterior with respect to the interior, and then you have to multiply it times the derivative of the interior here, which is, the f prime of x. Okay, it's just that we're going to write that thing, so we don't know what that function is. I don't have to isolate that particular function in order to find its derivative. We're just going to call it dy dx. Okay, so anytime that I have a y in my equation, whenever I go to take its derivative, I want to understand it is composed of multiple functions of x, and so I have to apply the chain rule to that and multiply it by a dy dx. That's what's about to happen right here. Okay, you're going to see how much simpler this was to just differentiate this thing implicitly. So I have y squared is equal to x, and I'm going to differentiate both sides with respect to x. So dy dx on this side and dy dx on this side. Okay, on the left-hand side, just think of it right now as just x squared. If you're going to take the derivative of that thing, then you would use the power rule, 2y. But y is composed of multiple functions of x, so we're going to multiply it times the derivative of y. So dy dx is equal to, and then the derivative with respect to x of just x is 1. All right, and then the last thing that I'd want to do is solve for y prime, or solve for dy dx, and I'll do that by just dividing the 2y over. So dy dx is equal to 1 over 2y. And we're done. That's it. There is the derivative. Hold on a minute. Hold on. Take a look what we had here. How is what we just found for the derivative implicitly, how's that the same thing as this right here? It doesn't even look the same. Well, kind of it does. I mean, it has a 1 over 2, but this one's two different functions, got plus or minus in it. And where's the square root of x? Well, I can force that, because watch. What was y equal to? Y is equal to plus or minus the square root of x. Remember, whenever we solve for it, it's right there. So now you can see that that function is identical to the one that we got. But we got it a whole lot easier. So back over here, here's this all nice and animated for us, taking the derivative of both sides, and since that's a function of x, then we have to apply the chain rule to it. And if you look over here on the right-hand side, you can apply the chain rule to the x, but when you do, dx over dx is just 1, so you know it's kind of pointless. And then you isolate the dy dx term. Okay, just kind of a recapping here. When differentiating implicitly, you're still differentiating with respect to x. So when you're differentiating and it involves terms that contain an x, you differentiate normally. So you're going to apply all your differentiation rules, like the power rule, any of the ones for trigs, exponentials, and so on. But when you're differentiating terms that contain a y, you have to apply the chain rule to it. So you're going to multiply it by a dy dx or a y prime because y is implied to be a function of x.